Hello guys, welcome back. Last time we talked about the circular functions and with the sine cos graph, right? And I was intentionally to make the final year exam questions for you guys to practice, but personally I think we need to go through the solutions of trigonometric equations and compare with general solutions. Then I can go through the final year exam questions with you guys. Okay, so for this videos, we're gonna continue work on our trigonometry questions, and later we can start to look at the final year exams. Okay, now let's look at 6e. So for 6e, we have solving the equations with sine t equals b and cos t equals b. Okay, so in this case, again, we need to use our 6b stuff to help us. Okay, so for example, we have the sine theta equals half or theta equals 0 to 4 pi, right? Then first we can consider how many periods we have. So for the basic one, the period is like 2 pi, right? 2 pi over 1, so it's 2 pi. So 0 to 4 pi, there will be 2 whole periods like this. And then we want the sine theta equal half, so we just make it equal to half. Then total we're gonna have 4 solutions. But the problem is, how do we get this exactly 4 solutions, right? So let's just make it in this way. First, I write theta and theta. Okay, write 2. The reason why I write 2 is because ASTC. So in one period, I got 2 theta or 2 sine theta can be positive half, right? So in such case, this is gonna be my first quadrant and second quadrant. Make sense? And then we look at the problems equal half, refresh our memories, is pi on 6 and 5 pi on 6. Okay, this is pretty important for us to know. And after that, we can do this way. So because of the period is 2 pi, so we can directly make 2 pi over n plus 2 pi over n and plus 2 pi over n, right? Then just make our n be the integer. So this is our general solution for theta. Every time I take a one whole revolution, I can get exactly half as required. Okay, so in such case, I let my n equal 0. I got 2 solutions, pi on 6 and 5 pi on 6, which is inside the required domain of theta. Then I let my n equals 1, so I get pi on 6 plus 2 pi and 5 pi on 6 plus 2 pi. Again, another 2 thetas are inside the required region. And if I let my n equals 2, suddenly we realize that, okay, they're out of boundary because it's over 4 pi. What about I let my n equals -1? Again, it's below 0, so not required in this case. Therefore, we got 4 solutions, which is indicated from this, and this. Okay, so again, for this type of problems, we just need to make sure we select or we pick the right one in the one revolution or in one period. Then we just adding the periods numbers to make other solutions available. Okay. For example 16, it will be the same, but in this case, we have to use the cast because it's not the special angles. Let's go down a little bit in here. They ask us to write down between 0 to 360, so technically 0 to 2 pi, right? But for this type of problem, they ask us to write in degrees. That's why we always need to write in our final answers in degrees. So for example, my cos theta equals square root 3 over 2, according to ASTC principle, okay? It must be on the first and fourth quadrant. So for the first quadrant, refer to our table, which I ask you guys to remember, is pi on 6, okay? And for our last one in the fourth quadrant is 11 pi on 6. So technically speaking, it's 30 degrees and 330. And as for the next one, sine theta equals negative half. So it will be on third quadrant and fourth quadrant, right? So we take back to our first quadrant, it should be 30, and then we move it to the third quadrant, plus 180. So it's gonna be 210. And again, for the next one, we take further to the fourth quadrant, it can be negative 30, but since our requirement from 0 to 360, so we just write 330, okay? Same thing apply for part C, but part C we have to shift a little bit because I need my cos theta equals something, okay? Instead of cos theta minus something equals 0. So in such case, my cos theta is equals 1 over root 2. So according to ASTC, it will be on first quadrant and will be on fourth quadrant. So on the first quadrant, it will be pi on 4. And on the fourth quadrant, it will be 7 pi on 4. Okay? Let's keep going. For this part, using the CAS to help you solve the problem, then you have to state the angles or the domain or interval required. Otherwise, CAS will give you some N or C after that, which means that's general solution, okay? Now let's try the same one or similar one, like this guy. We have sine 2 theta equals negative square root 3 over 2. And again, we treat the 2 theta as the whole thing, okay? 2 theta equals something. And now I need my ASTC, okay? So in this case, it will be on third quadrant and fourth quadrant. So for 2 theta, the first part, they must equals to what? In the third quadrant, okay? So 4 pi on 3, make sense? And the next one, it will be in the fourth quadrant. So it will be 5 pi on 3, okay? So these two. And then again, I just adding my period, which is 2 pi times n, okay? For different n values. And again, because we're looking for the theta instead of 2 theta, so my theta will be 2 pi on 3 plus pi times n, which is the first one. My second one will be my theta equals 5 pi on 6 plus pi times n. Okay, this will be it. And then I just plug the n values in. First, let my n equals 0. We got two solutions. When I let my n equals 1, we realize no, it's out of the boundary. I let my n equals negative 1. Yes, it's still inside. So technically speaking, we still have 4 answers, which is highlighted over here or in here. Okay. So this is purely algebra way, and of course, if you guys want to use like graphs from 6D, we can do it. And but for the graph, you have to be really careful. It only can give you how many solutions you're gonna have, but cannot really tell you the exactly values. So we still need to use our 6E to help us to get the idea. Okay, so let's do the quick summary for 6E. Again, we have to familiar with 6B, which is ASTC stuff, and memorize the special angles for 0, pi on 6, pi on 4, pi on 3, and pi on 2. Then use our circular function definition to help us find in whole one period how many solutions we can have. Then we just following the same procedures. Okay, let's maybe try another one. Like, just give me a sec. Maybe like this guy, cos x equals root 3 on 2. again ASTC, so it will be on quadrant 1 and quadrant 4 in one period. So my x value gonna be like pi on 6, and my next x value gonna be 11 pi on 6. Of course, you can write like negative pi on 6, same thing, okay? And then we just plus our period, which is 2 pi, and then we just times n, okay? Comma, comma, n belongs to z. Okay, we just need to do this, then we can get the idea of plug different value of n, like n equals 0, n equals 1, n equals -1, just inside the region, then we can get the answers, okay? So after the 6e, I think for 7 and 8, even 9, sorry, 7 and 8 are pretty important for you guys to practice, especially under the exam 1 condition, okay? Which is pretty important. And after this video, I think it's a good time to stop here. Next one, we're gonna do some exercise for this type of problems, the general solutions, and to ask you guys to familiarize or like experience the final year exams. Okay, hope this video is helpful for you guys, and I see you guys in the next video. By the way, please click the like and subscribe. Okay, see you guys. Bye bye.